Okay, so problem 14. If a single card is chosen from a standard 52 card deck, first it asks us A, what is the probability that it is red? So we're looking for the probability of a red card out of a standard 52 card deck. Well, we know that our denominator is going to be 52 because we have a total number of 52 cards to choose from. Well, there's 4 different suits. Well, let's not even think about suits. Think about colors. Half of the deck should be black and half the deck should be red. So we just have to take 52, divide it by 2, we're left with 26. Right? And that reduces to 1/2. So that's the probability of a red card. Now, for part B, it says, what is the probability that it is a king? Well, again, we know our denominator is going to be 52 because we have a total of 52 cards to choose from. But then we have to think about how many kings are in a deck of cards. We know we have 1 king for every suit, and there's 4 suits. So it's 4 kings. And that reduces to 1/13. So for part C, it asks us, what is the probability of choosing a king if it is red? So it's king given that the card is red. So for that, we have to remember our formula. For anytime we have something that's given to us, we have to look for the probability of king intersect red, and then we put the probability of the given on the bottom, which is the probability of the red card. So we're looking at the probability of a king and it's red. Well, how many kings are red in a standard deck of cards? Well, if there's 4 total, we have 2 red, 2 black, then we're looking at 2/52. And the probability of red, we've already figured that out. That's 26/52, right? So this is going to reduce. It's going to be 2/26, and that's going to reduce to 1/13. So that's our answer for C. Lastly, part D. Sorry, my dog's trying to play. Part D are the 2 events R and K independent or dependent? Mathematically explain. Well, we know that in order to figure out if something is dependent or independent, we just have to multiply the probabilities of both and figure out if they're equal to the intersection. So we know the probability R times the probability of K has to equal the probability of the intersection, and that's what we need to check. So we have 1/2 and we have 1/13. We've already figured both of those out. And we need to figure out if it's equal to 2/52 or 1/26. So we plug those into the calculator, we work it out, and it's equal. So we know that R and K are independent. Well, you know what? You can't even read that because of this marker, but I said it. So that's your answer. That's it.